Hi everybody! In this video I want to talk about combining like terms and distributing while solving equations. And distributing while we're solving equations. So first thing I wanted to talk about is that when you combine like terms, you don't have to worry about the other side because you didn't change the weight. So in a previous video, we were talking about how if you change the weight of one side, then you need to change the weight of the other side by the exact same amount so that the two sides remain balanced. So if I double the weight over here, I need to double the weight over here. If I reduce the weight of this by 5 stones, then I need to reduce the weight of this side by 5 stones. But, and that's still true, that's always true. The reason that we don't have to do anything to the other side of an equation when we combine like terms is because combining like terms does not change the weight of the side that we combined on in the first place. So let's take a look at an example here. We have 2x plus 1 plus x is equal to 7. So on the left side, I have 2 x boxes over here and 1 x box over here. I have 1 stone between them, and all of this is balancing out the weight of 7 stones on the other side. Now we could clean the left side up a little bit by combining like terms. So let's do that. So here I have a term with an x in it, and here I have a term with an x in it. So we can combine like terms, which means add or subtract them. In this case, we're going to add. I didn't put any subtraction in these examples. So everything here is going to be addition, but just be careful. If you're doing a problem yourself, you might see some subtraction or negative numbers. I just kept everything simple. But anyway, we can combine these terms here. We can put the 2 x boxes together with this x box. And what would that look like? You can see I put the picture right over here. So if we combine the 2x with this plus x over here, then we would get 3x. And we still have that 1 there. So 3x plus 1 is equal to 7. So this picture represents the original equation that we had, 2x plus 1 plus x equals 7. That's this one. But after we combine like terms, then we get 3 x's here instead of 2 x's and 1 extra x. So this equation is represented by this picture over here where we have 3x plus 1 is equal to 7, meaning it perfectly balances out the 7 stones. So it looks fine from the picture, and it is fine, but you should understand the reason why it's fine. It's fine because just imagine in your own mind, what would happen if I took this X box and I placed it over here? I still have the weight of 3 X boxes and 1 stone on the left side. So the weight of this side is exactly the same as the weight of this side. Okay? All I did was rearrange it, but I did not change the weight. And that's why if this stuff balanced out exactly 7 stones, then this stuff should also balance out exactly 7 stones because it's the same stuff. We just put the 1 X box on top of the other 2 X's. So whenever you're doing an equation and you combine like terms, you don't need to worry about doing anything on the other side. It's only when you would do something that would change the weight of one side, you have to do the same thing to the other side to change that weight also, so everything is still balanced. Okay, but not when you're combining like terms. So let's move on to the next thing that I want to talk about. You can only combine like terms if they're on the same side of the equal sign. So let's take a look at this example over here. Now we've got a bunch of stuff in this one, right? So remember, it's the equal sign that separates the two sides of the equation. So the equal sign is like this part of the scale over here, and it separates it into a left side and a right side. So on the left side, we have 3x, that's this, plus 7, that's this, plus 3 plus this, plus 2x, that's this. And on the other side, we have 2 plus 2x plus 4 plus 4x. So you can see all of that stuff over here. So right now, the two sides are exactly balanced out. Okay? I'm not actually going to solve this equation, just like I didn't actually finish this and solve this one. I just want to get these principles across. You could solve it on your own if you'd like to challenge yourself and see what value of x would make both sides balance out here and in all the other examples that we do. But I'm just going to go and talk about the concepts that I want to talk about. So you can only combine like terms if they're on the same side of the equal sign. So here, this 3x and this 2x, these are both on the left side. Remember, it's the equal sign is what separates the two sides of the equation. So this 3x and this 2x are both on the left side of the equation, so we could combine them. Okay. Also, we could combine the 7 and the 3 over here. Okay, we can combine, and remember, combining like terms, I can combine both of these because they both have x. I can combine both of these because they both don't have x. Okay, so we can combine those, and then on the other side of the equal sign, we also have some things that we can combine. We can combine this 2 with this plus 4 over here. Both of those do not have x. And we can combine this 2x with this plus 4x over here. Hey, those both have x's. So when we clean up, we have 3x plus 2x is 5x, and 7 plus 3 is 10. So on the left side, we should have 5x, okay, plus 10 stones. And you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So we just cleaned this stuff up. We put the x's together and we put the stones together. Okay, and then on the other side, we can put the 2x together with the 4x, and that would give us 6 x's. And we can also put the 2 together with the 4, and that would give us 6 stones. And that's what we have on this side now. 1, 2, 3, 4, 5, 6 x's. 1, 2, 3, 4, 5, 6 stones. So that's no problem. So I can combine this term and this term, and also this term and this term, because everything that I underlined in blue here is on the same side of the equal sign. Those are all on the left side. I can combine everything. I can combine the 2 and the 4 and the 2x with the 4x, because all of those things are on the right side of the equal sign. So as long as I'm combining like terms only when they're on the same side of the equal sign, I'm not going to run into any trouble. So you can see over here, the weight of this side did not change when I combined it like I did over here, and the weight of this side did not change when I combined those into what I have here. So if all of this was balancing out all of this to begin with, then all of this should still be balancing out all of this, because again, it's the same stuff. I just rearranged how everything looked. Okay, so that's not a problem combining like terms when they're on the same side of the equal sign. But let's go back to what I said over here, because I've been talking so long. I know I have a problem with that. I've been talking so long, you probably forgot the whole point that I was trying to make. You can only combine like terms if they're on the same side of the equal sign, not different sides. So let's look at an example where I have where I'm going to try to combine things that are on different sides of the equal sign, and I'm going to run into trouble. Okay, and I just gave a very simple example here. I don't even have any x's in this one. Just on the left side, I have 2 stones plus another 3 stones. And on the right side, I have 5 stones. 1, 2, 3, 4, 5. Yeah. So obviously, everything is nice and balanced right now, right? I have 2 plus 3, which is 5 stones on the left side. And I have also 5 stones on the right side. So right now, both sides are perfectly balanced, no problem. But what would happen if I tried combining? So by the way, I can combine these things. They're on the same side, and 2 plus 3 is 5. So if I wanted to, even though I didn't draw it here, I'll just draw it now. If I wanted to just move these and put them on top of here, okay, so that's like I combined the 2 and the 3 and I just put it in one big pile of 5. No problem, right? So I get 5 equals 5. Everything is perfectly balanced out. Not a big deal. But what if I tried to combine terms that were on different sides? So you might say, well, this term is just a 3. It doesn't have an x next to it. This term is just a 5. It also does not have an x next to it. So they are technically like terms. But we should not be combining them in this circumstance because the 3 is on the left side of the equal sign, the 5 is on the right side. So think what would happen if I tried taking these 3 stones and combining them with the 5 stones on the other side of that scale. Well, now I would have only 2 stones on the left side and 8 stones on the right side. Okay, if I moved these 3 over to here. So it's no good, even though if you're thinking, but aren't these like terms? Yes, they are like terms because both of them do not have an x and they don't have a y and they don't have a z or whatever. They are technically like terms, but since they're separated by this equal sign, if we try putting them together, moving all these 3 over here, we're going to get that scale to be unbalanced now, and that's no good. We want our scale to always be balanced every step of the way. So do not combine like terms when they're on different sides of the equal sign, only on the same side, okay? Now, the last thing that I want to talk about in this video is, just like we said, assuming we're doing it correctly and we're combining like terms that are on the same side of the equal sign, we don't have to do anything to the other side because the weight doesn't change. Okay, that's the first thing that I said at the very beginning of the video, if you want to go back to the video. Now I'm going to say something similar for distribution. If you distribute, so here we have a problem where we might want to distribute, right? So we have 2 times all of this stuff in parentheses. If you distribute, you don't have to do anything to the other side because just like the very first example that we talked about in this video, you didn't change the weight. If we distribute something, we're not changing the weight. So here's an example that we can look at to understand why we don't have to do anything to the other side if we distribute. So on the left side of this equation, we have 8 stones, okay? And on the right side, we have 2 times, in parentheses, 3x plus 1. So I'm going to represent that with 2 packages here. So the 2 represents 2 packages. And inside each package, imagine that we have 3 X boxes and 1 stone. So imagine you went to Amazon or something and you put in an order for 2 packages. And in each package that you want to arrive on your doorstep, inside each package, you're expecting 3 X boxes and 1 stone. So you have 2 packages of 3 X boxes and 1 stone. And let's pretend that the packaging itself doesn't weigh anything. It's only the stones and the X boxes that weigh something. So the weight of the packages, of the packaging itself is negligible. Okay, so all of these 2 packages right now are balancing, they're perfectly balancing out the weight of these 8 stones over here. Now, what would happen if we opened up these packages? So if I have 2, well, actually, I think I did the picture of it down here. So yeah, there we go. So what would happen if we opened up these 2 packages? That's like we're distributing this 2 over here. So if we had 2 packages and 3 X boxes in each package, then when I open these packages up, I'm going to see 1, 2, 3, 4, 5, 6 X boxes, right? So 2 times 3x is 6x, and 2 times 1 is 2. So if I have 2 packages and each package has 1 stone, then when I open up these packages and just lay everything out, I'm going to see 2 stones. Now, the important point here is that when we opened these packages and just laid everything out like this, we did not change the weight. That's the important point that I want to get across right now. Inside these packages, we had the weight of 6 X boxes and 2 stones all along. We just had them wrapped up in packages. When we unwrap them, which is like distributing, then we still have the weight of 6 X boxes and 2 stones. So if 6 boxes and 2 stones were perfectly counterbalancing the weight of 8 stones over here, then when we unwrap everything, this should still be perfectly counterbalancing the weight of the 8 stones on the other side. So there's no need when I distribute for me to change the other side at all. Okay, because distributing, it's like opening the packages and just laying everything out. So it might look different, but we're not changing the weight of what was on that side to begin with. So everything is still balanced. We don't have to worry about it. Okay, that's it. Have a great day.